Now let's take some examples. If you look at this circuit here, this is a volt source. It's a 10 volt. Then, of course, the VR will be 10 volt. Why? Because it is connected across the 5 ohm. 10 volt is connected across 5 volt. This point is connected to this point. This point is connected to this point. Then VR equal 10. VR equal 10. Okay, so now once you know VR, then you can calculate the current. How do you calculate the current? Use Ohm's law. VIR. Okay, VIR. Remember saying here, let me clean this. Delete. Okay. That you always need to calculate one of two things. You need to calculate voltage, you need to calculate current or power later on. Voltage or current. Okay. So how do you calculate voltage or current? First, you need to use Ohm's law. One way is to use Ohm's law. VIR. So how do you calculate voltage or current using Ohm's law? You must know two of these three. You must know two of these three. 1, 2, 3. If you know 2, you can calculate the third. Very easy, because V equal I times R. If you know any two of them, you can calculate the third. Okay, so the first way to calculate voltage or current is Ohm's law. Ohm's law. First way to calculate voltage or current is Ohm's law. Okay. Now assume that you don't have 2 out of 3. For example, you want to calculate the voltage and you don't know the resistance, or you don't know the current and the resistance. You don't know them. Okay. Or you know the resistance, you don't know the current, for example, and you want to calculate the voltage. Okay. So in this case, you can't use Ohm's law. You have to use Ohm's law. You have to have 2 out of these 3. Okay. So this is number 1. When I ask you to calculate voltage or calculate current, first think about Ohm's law. Okay. You can't use Ohm's law. If you can't use Ohm's law, what happens? If you want to calculate voltage, think about Kirchhoff voltage law. So you have to use Kirchhoff voltage law. If you want to calculate current, think about what? Kirchhoff current law. Kirchhoff current law. Okay. So there are 2 ways to calculate the voltage. First, Ohm's law. Second, Kirchhoff voltage law. And there are 2 ways to calculate the current. First, Ohm's law. Second, Kirchhoff current law. But remember, okay, Ohm's law is the first choice, but you must have at least 2 out of 3. Out of these 3, VIR. You must have these 2 out of these 3 to use Ohm's law. So here, for example, I have the voltage. The voltage equal 10. So now I can use what? I can use Ohm's law to calculate the current. The current equal what? Equal 10 divided by 5, which is 2 ampere. That's it. So yeah, I know the voltage. I know the current. You can calculate the voltage as a power. Power equal voltage times current. So 10 times 2 will be 20 watts. For the second example, the current is 4 ampere because this is a current source. If you have a current source, you know the current, then I equal 4 ampere. I equal 4 ampere. That's very easy. And again, since you know the current and you know the resistance, then you can use Ohm's law. Why? Because you have these 2 out of 3. Then you can calculate the voltage using Ohm's law. That is 4 ampere times 3 ohm will be 12 volt. And you multiply 4 times 12 will be power. Look at this example. It says that this LED has no resistance. There's no resistance here. Okay, the resistance is 0. So now assume that you have this source. This is a battery. You have a battery like this. Okay, so this 9 volt, and you connect it directly to 0 ohm LED. Then in this case, the current is infinity because you have applied 9 volt over 0 resistance. Then if you use Ohm's law, it will be 9 divided by, the current is 9 divided by 0. 9 divided by 0. Then in this case, you have a problem. You have a problem. So again, here it is. VIR. The voltage is 9 volt. And the resistance is 0 ohm. The current will be infinity. 9 divided by 0 is infinity. Okay? So it will not work. I is infinity, as I said here. Okay? So how do you make the current? They said the maximum current is 30. So I want the current, this current here, to be 30 milliampere, which is 0.03 ampere. 30 milliampere is 0.03. So I want the current to be this, okay? But now it is infinity. It's not 0.03, it is infinity. So it will not work. So how can you design the circuit so that the current is 0.03? To limit the current, you need to add resistance. Okay, the resistance, as I said, the resistor is the element that resists the current. Okay, but if you don't have resistance, there's no resistance for the current. The current will be infinity. And this is what we have here, because this is short circuit. It's infinity. It's 0 ohm. So the current is infinity. So we need to add this resistor. So in this case, okay, we have to use Ohm's law. So the voltage is 9 volt. Okay, what is the current? The current is 30 milli is 0.03. 30 milliampere or 0.03 ampere. So now we need to know what's the resistance. Now the resistance is very easy. You can calculate the resistance. It's not a problem. The resistance will be what? Will be 9 volt divided by 0.03, which is 300 ohm. So R supposed to be 300 ohm. That's it. Okay, again, how? This 9 volt divided by 0.03, which is 30 milli. So again, it is 9 volt divided by 0.03 equals 300 ohm. So the resistance here is supposed to be 300 ohm. Okay, so this is the solution of this example. This example is about Kirchhoff voltage law. There is another way to use Kirchhoff voltage law, which is just try to follow the nodes. You don't have to use Kirchhoff voltage law. So, for example, here, you see this one is 10 volts. This is a 10 volt source. So this is positive. This is negative. Okay. This is a ground. Ground means 0 volt. So it is 0 volt. Okay. So this means that this branch, the whole branch is connected to the ground. This one is the whole connected to the ground. So this is all 9 volt. Okay. So if this one is 0, this point here is 0. So can I calculate the voltage here? Yes. It's 10 volt. This one is 10. Why is 10? Because if this one is 0 and you have a 10 volt here, the source is 10. So this is 10 volt. The difference between this point and this point is 10. Okay, one of them is 0, the second one is 5, is 10. Same for this point here. This point is 0 volt. This point is 0 volt. Okay, so what about this voltage? It will be 5. Why it is 5? Because it's positive. Negative. Let's erase this one. Okay. This one is 5. This one is positive. This one is negative. The negative is 0, since the positive will be 5 volt. Okay. So now I can calculate V1. I can calculate V1. But before I answer this, okay, why didn't it, if my question is to find I, if I want to find I, can I find the I? No. It is. Let us apply Ohm's law. I want to calculate V1 or I want to calculate I. Okay. How do you calculate I? It is V1 divided by 2. So you do not have 2 out of 3. 2 ohm is known, but V1 and I are not known. So you cannot apply Ohm's law right now. Okay, but now I can calculate Ohm's law. Why? I can use Ohm's law. Why? Because I know V1 now. What is the value of V1? V1 is the positive side. This positive side is 10. Negative side is 5. So V1 equal 10 minus 5. I'm sorry, what's happening here? So 10 minus 5. 10 minus 5 is 5 volt. V1 is 10 from the left minus 5 in the right. That is 5 volt. Now you can apply Ohm's law. You can apply Ohm's law. So the voltage is 5. The resistance is 2. Now can I calculate I? Yes. So I equal what? 5 divided by 2. 5 divided by 2 is 2.5 ampere. 2.5 ampere. Okay. Let us see this one. Let's forget about the 2 in the right now. And we do the same. We have the same concept. We cannot use Ohm's law for the 4 ohm. Why? Because we do not have 2 out of 3. We do not have 2 out of 3. Okay. So now let us see how can we start or work on this. This one is 0 volt because it is ground. This one is connected to the ground. Same for this one. This one is also 0. Okay. What about the voltage here? I know that the difference is 10. It's 10 volt. Positive, negative. Then the voltage here is what? It's 10 volt. So from this side, it's 10. This point is 10. And this point is 0. 10 minus 0 is 10. Okay. Second, here, this one is 0. This one is, I don't know. Let's see. This one is negative. This one is positive. Okay. So you cannot say this one is 10. No. It's supposed to be negative. Why? Because it's connected to the negative side. And now you can calculate the voltage here. The voltage is 10 volt. It's a positive 10, of course. Okay. But it is what? The bottom side, the positive side, which is this one here, minus the other side, which is the negative side. Okay, let's now calculate it. This side is 0. This one is negative 10. 0 minus 10 will be positive 10. So this voltage here is negative 10. It's negative 10. Now we need to calculate V1. Okay, so V1 will be the positive, which is, my God. Okay, so here it is. Let's erase this one. No, to erase it. Erase. Okay, let us pin. So this one is 10, and this one is negative 10. So V1 will be what? Will be 10 minus 10 will be 20. 20 volt. V1 is 20 volt. What's the difference between 10 and negative 10? Don't tell me 0. It is 10 and negative 10. The difference is 20. 10 minus 10 will be 20. So now you can calculate or use Ohm's law. You can use Ohm's law. You can use great Ohm's law. Here it is. The voltage is 20. The resistance is 4. Can I calculate the current? Yes. I equal what? 20 divided by 4. 20 divided by 4, which is 5 ampere. I equal 5 ampere.